Hello everyone, and I'm back with a final update on my Breath of the Wild map project. Now, I had a live stream a couple of weeks ago where I went through constructing the map, but I thought I'd come back with one final video update to sort of show off some of the different angles, explain some of the process, and bring you some highlights from that honestly rather too long video. It's still there though if you want to go watch it. So first of all, I want to talk about the maps itself. And in particular, I want to show you the size difference between my prototype and the original. And what's very exciting is I now have an overhead camera thanks to some honestly rather worrying jury rigging of a GoPro with a clamp, but let's cut to it now. So as you can see, this here is the prototype map, and it is US letter size. That is 8.5 by 11 inches for those of you like me who do not understand US paper sizing. Now it's the largest size I could print on a normal laser printer. And one of the nice things I've found about this map is that even though it was supposed to be like a quick test, the use of a laser printer actually has been kind of amazing. The color reproduction on this, laser printers tend to oversaturate colors a lot, and my one is definitely one of those, but it really helped make the map pop. And funnily enough, like the way this looks helped inform my final version over here. And it's honestly kind of great. But yeah, like this is the prototype. I've showed this in a previous video. This is the final finished version. It is printed on the largest paper I have here that I can print on. That is US Super B, which is 13 by 19 inches. Gotta love inches, don't you, America? And it is, as you can see, substantially bigger. It's not a whole lot bigger, but if you tile this on there, it's probably it's over twice as big in terms of area. And one of the differences here is that while this is printed on a laser printer, obviously this is on an inkjet printer. Now, one difference you can kind of see on the video here is the color difference. And again, the GoPro's not giving you exactly great color reproduction here, but there is more of a sort of yellow earthy tone to the full version, and there is more of a sort of blue and like slightly washed out tone to the laser cut version. This is actually printed directly from the game files. I kind of let the laser printer just do what it does. And as I said, I like the look so much, I color corrected when I built this bigger version. And I took the files, I tried to make them a little less yellow and brown. They were initially very golden looking in the source tiles. I think maybe they were designed to work well on the Switch screen, must have a different color balance. And I sort of brought them out, made the blues and reds a lot richer. And as a result, I think the end result here is pretty nice. It's maybe not quite what I would like. I probably could tweak it a little bit more, but honestly, it does seem a bit more like the actual game than this initial version does, even if this is a bit more pleasant in the blue sense. So that was one of the other things. The second thing I did was I increased the height of these layers by one sheet of what here in the US is called poster board. Now, if you didn't see a previous video, the way I make this sort of cardboard these layers here are made out of is I took two sheets of poster board, glued them together, and then glued on this small one a piece of laser printed index paper, that's just somewhat thick cardboard you can print on, onto this to make a 3-layer sandwich. This bigger one is 3 layers of poster board and then semi-gloss as the printable layer on top of that. And one of the things you have to do is you print out the nice layer first and then you have to lay it on, because obviously my inkjet printer cannot print on sort of 3mm solid sheets of stuff. I wish it could, but it just can't. The thickest it can print is about 0.5 millimeter, and even that's kind of like a weird paper path through it. So once you do that, you kind of have to assemble them as these big pieces, and then you take them and you stick them in the laser cutter. Now, I recorded a sort of short VT for my little live stream, so I'm gonna cut over to that now, and me from the past will walk you through some of what it takes to take these sheets and load them into the laser cutter, and a little bit of action of the laser too, see how it cuts. So over to me in the past. Thanks, me. So you join me here in the garage, and we're here to cut a few more of the sheets for the map. So first things first is I've already masked these ones. If you watched my previous live stream, you'll see me doing this very slowly and systematically. But essentially every single edge the laser is going to cut through, we've masked off with this blue painter's tape. That's to stop the laser discoloring the edges as it goes through. It's not actually the laser, it's the smoke that comes from it, but it leaves this weird yellowish orange color on the paper. So we've masked it to prevent that. The tape will catch the smoke and we'll peel it off later, hence painter's tape. It leaves no residue, and that will help us do everything. So time to put this in. I know this is page 5. I've got the reference up on my computer here. So I'm going to place it in and I'm going to line up the outline of it manually because I haven't still yet got a good registration system for lining it up automatically. So you can see here the laser interior. In particular, there's a small red dot under the laser head right here. Now, that red dot isn't the actual cutting laser. It's a secondary laser that you use for positioning, but it goes through the same optics. So we know that where that dot is where that actual laser is going to cut later on. So my first task is to line up that corner like this with the corner of this black outline. In the software, I made it output an outline around the edge of the piece. Let's put it about there. And in the output, both the picture and the cut lines have this built-in rectangle. So I use it for manual registration, that is lining up of where everything is. Okay, that looks pretty good, at least by eye. It's probably not correct, so I'm going to run what's called a framing command, which will make the laser go around what it thinks is the edge. Okay, that's pretty spot on left-right, but it's a bit off in the vertical. So reposition it very slightly and try again. Okay, taking a closer look, I can tell it's rotated slightly. So the nice thing is this honeycomb here is on magnets rather than being bolted down. So I can manually move it a little. Oh, that's still a bit off. There we go, let's try that. Oh, that's much better. Okay, I'm just bang on. One more tiny tweak. Of course, if you do it wrong, you can ruin the whole thing by just moving it with your hands. There we go. Now, by eye, that looks pretty much dead on. So we are going to close the lid. So I've positioned the laser outside of the protective top here. That's why it's colored a little yellow. It blocks the wavelength of the laser, so it's not going to harm me or the optics of this rather expensive camera. In future, I'm going to try to stick a GoPro directly inside there, because it's almost certainly going to be fine. But for now, I'll just view it from outside. So now I've got the cut in, I'm going to make sure I've got my air flowing. So I've got my exhaust fan. You can probably hear that in the background as a low hum. That draws the air out. We're also going to turn on the compressor. That's going to push the air through the nozzle to prevent smoke going into it. Smoke going into the nozzle is bad because it tends to get on the focus lens and the mirrors and generally defocus the lens and make it melt itself rather than the thing below it. So good, we're ready to go. The temperature looks pretty good on the chiller, so let's hit go. This whole process takes a while. This one's estimated to run in at about 4 minutes. So we'll jump ahead a little bit and see how it looks like after the end. All right, so now we've finished cutting, so we can open the chamber, make sure the head is as far back as it can go, and just make sure we've cut through properly. So I'm going to lift the edge here, and you can see some nice clean cuts through. It's pulling away very nicely there. So I'm just going to put a little bit of tape on these to keep them in place as I lift this out. All right, I've taped it all up, so we're going to lift it out, make sure it's going to hold together. Oh, I missed one piece. I always miss one piece. But there we go. So I'll get to cutting a few more of these, and until then, back to you in the studio. Thanks, Me. So now we've seen that, you kind of understand that laser cutter gives you, in the end, a set of what I like to call jigsaw pieces. And it's then the job to take those pieces and glue them down to form this final map. So that process is kind of what I showed in the live stream a few weeks ago, and I'll show you a few bits and pieces here, but Essentially what you have to do is you have to take each individual jigsaw piece and roughly arrange them by height, because of course you have to glue the base layer first and then go up in elevation as you glue. And that's usually pretty easy. There's a nice feature that there's no underhangs on this map, so things get smaller as they go upwards, but it's not always perfectly easy. And so one of the difficult things is I had to sort of identify what pieces went where. The smaller the pieces got, the more difficult it became. There are several very small mountaintops on this map that are kind of similar if you look at them without a reference point. And so what I got is I had this thing I called the layout guide. And the layout guide lets you essentially look at what each layer should be, and it sort of highlights a ring around each layer, and it tells you, sort of shows you in context on the map where it is. And what that lets you do is it lets you essentially go, well, I need to find, say, the top of this mountain, and you can go and look through your set of jigsaw pieces and then pick out the right one and then know where to put it on the map. And this was kind of built up over a series of trials, including with my prototype map. And in the end, the system I have is pretty good. As you'll have seen if you watch the stream, it does take about 2 hours to put all the pieces together, but most of that is just gluing and arranging. Not much of that is confusion. I did manage to lose a couple of pieces, which I then managed to find stuck to a wad of masking tape over in my bin, so that solves that mystery. And the only real problems are two kinds of pieces. One, pieces that look very, very similar on height. I'm actually going to pull up close up here of one of those pieces for you to see. So here we have sort of the edge of the map, and this is, I think, the only feature on this map that isn't part of the world you can travel to. It's actually sort of out of bounds. Link will die if he tries to go there. But it has this kind of fun feature here, which is, if you look closely, very similarly shaped all the way up, and that makes it a little bit of a pain to do. It's probably the worst one on the map for this. As I said, there are other pieces on the map that are similar shapes. Things like these small mountain tops here tend to get a little bit confused with each other, but generally the tree layout lets you disambiguate a lot of those. Now the other problem is pieces with very small ends. What I mean here is that, like, a lot of mountains obviously aren't just nice round blobs, they have ridges and ridge lines. And on maps, those come out as contours that are long and thin. Now, if you just blob a bit of glue in the middle of something and stick it down, those edges are going to peel up over time. And so one of the things I had to do during the actual construction was take those pieces and not just put glue in the middle of the piece, but make sure I rubbed glue along the edge to get a good solid layer of adhesion along that whole edge piece. Now, thankfully, the glue I was using was sort of normal PVA glue, so it's safe for me to touch. It just peels off when it's dry, so I can do that with my finger. Obviously, if it's super glue, you would never do that. You'd have to use a glove or something else, but this is why I used pretty safe glue, because this thing is going to go inside. It doesn't need to be water safe or anything like that. It's fine. Normal paper glue is fine. And that's kind of the main two things. Like, some of those gluing things did peel up, so I had to go in here with a toothpick in the intervening weeks and just dab tiny pieces of glue in under a few pieces that were peeling up. But now it's been about a week since I had to do that. It stayed pretty solid. And there's only one remaining issue, and I'll pull up the overhead camera to show you that one. So as you can see here, the edge, if I hold it up to the camera, of this is not perfectly straight. There's a kind of a bend to the whole board that kind of pushes this way. And that's a problem mostly, I think, due to that lamination process, where I said, I use 3 layers of poster board glued together to make this the right thickness. And I think part of that process, even though I put them in a press and hold them flat, adds some kind of little curving to the paper. Now, why did I use glued together poster board? Well, the answer is the edge cut. So when a laser cutter cuts things, it is not cutting in the sense of like a knife. It is more an obliterator. It literally just removes the material under the laser head and atomizes it. It basically makes it into gas in most cases. And so what that means is it burns as it goes. Now, some things like acrylic, this is lovely. Like, it polishes the edge of the acrylic. It looks really nice when it's cut. But things like paper and wood, when they're cut, burn. And they burn, obviously, a darker shade than they were. So if you cut things like normal wood or plywood, you get this very solid, like almost charred black edge on it. And that's true of also like normal brown cardboard too. If you cut that, you get a pretty like sort of dark edge. The nice thing about this bleached white paperboard is when you laser cut it, it goes like this nice light brown. When you're making a terrain like this, that's almost exactly the color you want. So that coloration is honestly mostly the reason I kept with my system of just gluing together layers. I do have a set of different paperboards and cardboards, whatever you want to call them, of various thicknesses. That there is one that is just the millimeter and a half thick that this actually ends up being. But if you cut that, it has a very dark edge on it. And I think if the map was a darker color or maybe more of a aerial imagery, we'll get to that later, it would look fine. But for this, it wasn't ideal. So let's talk about next steps. Now, obviously I have the map. It is a nice size. It can just probably go and hang on the wall. Framing it's gonna be fun, but I plan to either buy a frame that's a bit bigger and sort of inset it, or maybe even make my own frame. Might finally be time to buy a miter saw if I can justify that. But that's kind of not the end of the road. There are other maps I want to make as well. I think the most obvious other map in terms of a landscape that inspires me, what I call a sense of place, is Skyrim. And I found a pretty decent couple of sets of overhead view tiles for Skyrim, and I'm pretty sure I can get an elevation map for it as well. My main problem there is that it's not done in a map style. It's done in much more of a sort of aerial imagery or satellite imagery style, and that can be difficult. And to explain why, let's talk about my other project. So obviously fictional areas are one of the key things I want to work on, but the other thing is real areas. I live in the great state of Colorado. Half the state is very, very flat and boring, but the other half is full of some of the tallest mountains in the continental United States. And as a result, they're really good places to make these relief maps of. And so I've done a little test, which you can see here. I'll zoom in a second. And basically this is just taking a small section of the Rockies. In fact, this is the section where the I-70 climbs up into the Eisenhower Tunnel, and just trying to use normal aerial imagery. I forget what the source was, probably a NASA source on this one. Overlaid with elevation data, which of course we just have for all of Earth. That's pretty easy to get these days, and see what it looks like. So let's pull up the close-up and I'll show it off a little bit. So as you can see, it does look reasonably like the real thing. Not that the real thing is easy to experience unless you've got a small plane, and I haven't yet got up to flying myself around out here yet, working on that one. But there is a slight difference to the sort of drawn map of Breath of the Wild. Breath of the Wild is designed as a map. It is beautifully drawn. All credit to the artists who made it. But aerial imagery, it's not quite the same. One of the features you don't notice on the Breath of the Wild map until you look at it properly is that it has this elevation shading. It gets to a lighter color as it goes higher. And that's kind of true of this. You can see here, this was taken with the snow on the top of the mountains. So there's kind of that effect. But most of these forested mountainsides are pretty dark. And so I do worry that blown up to a larger size, this will not look great. So I think more experiments are required here. This initial test piece, the reason it's the size it is, it can all be done in a single sheet in laser cutter. So I print out one sheet, I cut it, and I'm done. But I think there's more to be done here in terms of scaling it up, trying a few more things and seeing what I can do. There's also the question of using real-world maps. Now, unfortunately, back in my home country, there's a wonderful set of maps made by the Ordnance Survey, which are almost iconic. There's these beautiful maps of the UK in all areas in different sizes, and they're kind of what many people who learn to hike or walk in the UK use. At least when I was growing up, I'm sure it's much more Google Maps these days. But in the US, there's kind of less of that. And one of the issues is the USGS do a fantastic job. They've got a huge amount of data on the US in general, but a lot of their actual drawn maps or authored maps are mostly from the 1950s and earlier, back when people were still authoring maps. A lot of the modern maps are just tile sets, and one of the annoying parts is they have hill shading built in. Now, you're not familiar with what hill shading is. It's when you sort of take elevation data and you fake shining like a sun on it, and you darken, let's say, the western or eastern sides of mountains to give us a 3D effect when viewed in a computer. Of course, this is only useful on a computer. If I'm printing them out like this, then hill shading is honestly not very useful. It's gonna make it look worse. And so finding a non-hill shaded base map is honestly pretty difficult. You can get away with light hill shading. And the other problem is most of those maps don't show what's called land cover. They're just kind of showing roads or features or things like cities. What I want is a thing a bit like what the Breath of the Wild map has, which is essentially showing land cover. land cover, in case you're not familiar, is what's on the land. Things like forests versus fields versus, you know, tundra or like rocky mountainside. And there is a data set of this. The USGS, I believe, or one of the government agencies here in the US, releases a full land cover data set. And so I've done a few experiments in QGIS. I've tried to combine them and make a map that looks pretty good. That's still an ongoing process. There's also been some really nice, like big national scale maps recently that draw from land cover data. So I'm going to try and take one of those, maybe of the whole state of Colorado, and do a Colorado relief map, which is very convenient because Colorado is literally a boring rectangle. So it fits perfectly on this kind of map size here. So that's kind of the next set of projects. But until then, I think the Breath of the Wild project is done. There's a few things in sort of on the burner for maps. The immediate next project is not maps, it's something else that I'll do another video on soon. A little model making, it's fun. But yeah, so it's been pretty good. I'll leave you with a few glamour shots of the map, just so you can see like how it looks like. These maps are kind of hard to film or photograph. It's true of the 3D printed map cities as well. And so like you have to like basically take these studio lights, lower them down, have like a nice side angle to get the shadowing properly. So leave with a few shots of that, and I'll be back with more maps and other things in future. But until then, I'll see you next time.